and we're moving into integer. We're moving into exponents. We're going to do a lot with exponents in the upcoming lessons. So some reviews, some things you should know about exponents. The product rule, some laws of exponents here. So the product rule for exponents, if you have x to the something times x to the something, so let's say you have x to the third times x squared, all right, that's just an example of this. You would get x to the what? Would it be x to the sixth? No, it would be x to the fifth because you add exponents. X to the third is x, 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 x squared is x, x, and that adds up to x to the fifth. Okay, so we get x to the a plus b. Division, this would be x to the a minus b. Raising a power to a power. If I have x squared and I raise it to the fifth, that's x squared times x squared times x squared times x squared times x squared. 2, 2, 2, 2, 2. There are 10 of them total. The shortcut is you just multiply those exponents. So when you're raising it, you multiply x to the a times b. Power of a product, this would be x to the a, y to the a. So if they're both in parentheses to the a, they both get raised individually to the a. Same thing for quotient, x to the a over y to the a. And then 0 power, anything to the 0 power is 1. Any number to the 0 power is 1. 5 to the 0 is 1. 12 to the 0 is 1. Negative 4 million to the 0 power is 1. All right, here's the reason why. Or no, this is going to review negative exponents for us. A negative exponent rule, and this is something you should already know as well, but using the quotient rule, what is the quotient? So I have x to the third over x to the seventh. What happens? Well, I subtract the exponents. So that gives me x to the negative 4. Now, let's write out what this means. X to the third is actually x times x times x. And x to the seventh is actually x times x times x times x times x times x times x. Okay? Now, what happens? Well, I have reduced to 1, reduced to 1, reduced to 1. Remember we did that, reducing to 1? So what's left on top? Just 1. And what's left underneath? X to the fourth. So same exact starting rational expression. Same exact starting fraction. X to the third over 7, x to the third over x to the seventh. By using the quotient rule, we get x to the negative 4. By writing out the terms and reducing to 1, we get 1 over x to the fourth. So this kind of proves to us that x to the negative 4 is the same thing as, these are equal, x to the negative 4 is 1 over x to the fourth. X to the negative 4 is 1 over x to the fourth. So that applies for any. That's the general rule. So x to the negative a would be 1 over x to the positive a. So basically, if you have a negative exponent, you make it 1 over, you flip it, and you make it positive. All right? So here's a little example. If you have the, now here, x is raised to the negative 4, y is raised to the negative 3, and 2 is raised to the first. 2 is raised to the first. So the 2 would not move. That would stay where it is. X to the negative 4 moves down and becomes x to the fourth. And then y to the negative 3 becomes y to the third. All right? And it moves up. So any negative exponent moves down. If it's in the bottom, it moves to the top. 2y to the third over x to the fourth. If you want to write this without a denominator, you'll say 2x to the negative 4 and then y to the third. If you just want it to not be a fraction, you could write it that way. So there's 2 different ways to write this, 2 equivalent ways to write it. All right, so we're going to bang out some examples here using our properties. 5 times negative 3 is negative 15. X to the fifth times x squared is x to the seventh. And that's it. Can't do anything from there, right? Here we have 5. Everything's to the third. So 5 to the third, 125. Actually, let me write that out. I don't want to confuse you. 5 to the third. X to the fourth to the third is x to the 12th. And then y to the third is y to the 9th. That's using the power, raising it to a power rule. And then 5/3 is 125. So 125, x to the 12th, y to the 9th would be your final answer there. Here I have 1 over 2 x to the negative 3. Remember we said that x to the negative 3 is going to come up top, and this is 1/2. So it's 1/2 x to the third. 1/2 x to the third. This one, the whole thing, the 2 and the x, are all raised to the negative 3. So this whole thing comes up to the top. So it's going to be just regular 2x to the third, positive 3, over 1 basically, right? And now we're going to use our raising to a power rule like we did here. 2 to the third is 8, and then x to the third is x to the third. So 8x to the third. See the difference between, I want you to notice the difference between C and D. The only difference is they put parentheses around the 2x, and here they didn't. So here, without the parentheses, the 2 stays in the denominator, so it's 1/2. But here, with the 2 in parentheses, that 3 applies to it, which became 8. Not only that, because it was a negative 3, it moved it to the denominator. So that made a big difference having the 2 in the parentheses, and here having it not in the parentheses. All right. Let's see, 5 to the negative 3. So let's do this individual. 5 to the negative 3. And then x to the negative 6. And then y to the 12th. And then z to the negative 18. So there we go. And then 5 to the negative 3 is 1 over 125. So we're going to write it as 1 over 125 times all this. X to the negative 6th, y to the 12th, z to the negative 18. That's going to be our final answer. If you want to get rid of the negative exponents, you move, this should be negative 18, sorry. And then we move these down. If we wanted to get rid of the negative exponents, we can move them down. That's not what they're asking us to do here. All right, here, 12 over 2. 12 over 2 is 6. And then a's, that reduces to 1. And then this is b over b squared, so we got to subtract the exponents. 1 minus 2, b to the negative 1. So 6b to the negative 1. 12 divided by 3 is 4. Use your rule. Negative 3, and this is a 1. Negative 3 minus 1, guys. Negative 3 minus 1 is negative 4. And then 2 minus 5, negative 3. So there we go. And then everything to the negative third. So this is what I'm going to do here. Let's make this a positive by flipping this. X to the positive 22. 3x to the 22. And negative 3. Because that moves up because it has a negative exponent. Now, the negative 3. 3 to the negative 3. 3 to the negative 3. And then x to the negative 66th. Okay, and then 3 to the negative 3 we can do. We can just do 1 over 3 to the third. 3 to the third is 27. So 1 27th, and then x to the 66th power. 1 over 27 times x to the 66th power. Oh, negative 66. X to the negative 66. All right, example 2. If a equals 2 and b equals negative 4, what is the value of this expression? All right, so a is 2. So we're going to plug that in. 2 raised to the negative 3. And then negative 4, we're going to plug in. That gets raised to the negative 2. And we could actually put this in our calculator, but we're going to do it the long way here. Because they have negative exponents, if it has a negative, I'm going to move to the bottom. Negative exponent moves to the top. So this whole thing moves to the top. It's going to be negative 4 squared. And then this is going to be 2 to the third. See how that whole thing moves down, and so this moves down and this moves up basically. All right, and we get, now we can do this. Negative 4 squared is 16, and this is 2 to the third, which is 8, and then 16 over 8 is just 2. So this simplifies down to just 2. A couple more and we're done. Nice short video today. Rewrite the expression x squared to the n times x to the third in this form, where k is a real number, n is an integer, and x is non-zero. All right, so x squared to the n is going to be x to the 2n times x to the third. Now we have to be careful. We have x to the 2n times x to the third, right? This time we have to use our, go back to the front page, we have to use this right here, this rule, product rule. X to the something times x to the something, see? And what do? You add the exponents, all right? You add those exponents. So it's going to be, this is going to be equal to x raised to this plus this, 2n plus 3. And I'll put that in parentheses because it's a binomial. So x to the 2n plus 3. And that's all we can do. All right, x to the 2n plus 3. We don't know what n is, so we have to leave it like that. And that's kind of what you're gonna see in that Common Core. What's going to be going on there is a lot of students think, oh, it's 6n. No, it's not, because you add exponents. 2n plus 3. 2n plus 3 is that exponent. So if you thought it was 6n, just think about you're multiplying, so you add exponents. All right, last one here. If a equals 2b to the third and b equals this, express a in terms of c. Wow, this is a little crazy here. The one you're going to have to do in the group is not going to be, with your group's not going to be as bad. But this one's going to be about as bad as you would see. All right, so I want to express a in terms of c. Okay, so what I need to do, what I want to do here is I want to plug, if I'm expressing a, I want a equals. So I'm going to leave it. I already have a equals. A equals, but I want to express it in terms of c. So here's b right here. Look at that. Here's b, and here's an expression for b. So I'm going to plug, I'm going to substitute this in for b right here. That b right there, I'm going to take that b out and put this expression in. Why? Because this expression is equal to b. See? This expression equals b. I'm going to leave everything else where it is. So 2 times b, right? B is this, negative a half, c to the negative 2, and then to the third. So all I did, I took that 2b to the third, and I took out b, and I put in what b is equal to. I put in this b expression. This is a b expression right here. Now I'm going to simplify this. 2 times a half is just 1, so but it's a negative, so it's going to be negative. The 2's kind of like cancel, right? 2 over 1, that's just 2 times a half is just 1, right? Now, so I have negative c to the negative 2. I messed up. Sorry. I did the thing you cannot do. You have to raise it first. So I messed that up. That 2 is there. That 2's still there. 2's don't cancel. You have to do exponents before you multiply. Did anybody else notice I did that? Okay, so 1/2 to the third is 1/8. So negative 1/8. 1/2 times 1/2 times 1/2 is 1/8. All right, and then c to the negative 6. There we go. Because you have to raise it, multiply, right? Now I can reduce 2 and 8 reduces to a 4, and that's a 1. Okay, so now I have negative 1/4 c to the negative 6. There we go. Negative 1/4 c to the negative 6. That's going to be our expression of a in terms of c. That's what a equals. A equals negative 1/4 c to the negative 6. I'll see you in class tomorrow for some more practice on exponents.